how you factor a quartic polynomial, or in other words, an equation that fits quadratic form. So something is in quadratic form, so we know our standard form of a parabola is ax squared plus bx plus c. So when we're talking about quadratic form, we're looking for something that's a trinomial, so there's three terms. There's a constant term, so there's a term with no variable on it, which we have here, right, the -8, no variable, and where the highest degree is twice the middle degree. So in other words, what we could do is we can say, well, we can kind of like fiddle around with this a little bit and say, well, this is really x squared all squared plus 7 times x squared minus 8. So in other words, this degree, the top degree, is twice the degree or exponent of the middle term. So if that's the case, you can treat this like factoring a normal quadratic equation, but instead of putting an x into your parentheses sets, you're going to put, in this case, an x squared, or whatever that middle term is. So we're going to factor it like normal. So in this case, I want to multiply to -8, and then I want to multiply out to positives. I want to multiply to -8 and add to +7. So the two numbers that'll do that for me are going to be, let's do a different color. We'll do orange. If I multiply +8 and -1, right, those multiply to -8, but add to 7. So what I'm factoring, I'm going to set up my two binomials, and because there is no leading coefficient, right, the leading coefficient is 1, there's nothing in front of that front term there, I can jump straight to putting my variables in here. So I'm going to put x squared here for both of them, right? I'm going to put an x squared there because x squared times x squared would give me back x to the 4th, which is my highest degree. And then we're just going to put in those two numbers that we just found. So +8 and -1. So now the tricky part of factoring in quadratic form or a quartic equation like this is you need to check for difference of squares equations or any other sort of special equations that might pop up inside those parentheses sets. So if we look here, right, x squared minus 1, that's not the color I wanted, right? This is the difference of perfect squares, right, which has a special factoring pattern. So we want to break that down even further. So I'm going to break that down into two groups. So the square root of x squared is just x, and the square root of 1 is 1. And then I'm going to put my opposite signs in the middle so they cancel out. And then x squared plus 8 is not a special factoring form because 8 is not a perfect square and they're being added, so it wouldn't be difference of squares. So we're just going to bring that group down. So this is our overall complete factoring. So whenever you're factoring in quadratic form like this, if you start with a quartic polynomial, you want to always check for those difference of squares equations that might pop up. And if they do pop up, you're going to want to factor